Adding and subtracting radicals. You don't have to write this down, but I'm just going to ask you a couple of questions. What's 2x plus 3x? What do? Add the numbers. Don't overthink this. It's 5x, so how did you get it? 2 plus 3 and put an x on it. Why isn't it x squared? Because it's not multiplication. It's the same thing. 3 plus 1 is 4. Why? Oh. 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 Why do you always assume you can do something to it? No, you're not multiplying them. If you multiplied them, it's 2xy. You're adding them. What's that? Right. You can't do anything. You can't, they're not like terms. You can't put them together. Okay? So given this, what do you think this must be? 5 root 5. What do you think this must be? 6 root 10, because root 10 is the same as 1 root 10. So adding and subtracting radicals is just like adding and subtracting variables. In order to combine them by adding and subtracting, they have to have the exact same variables. Well, for radicals, they have to have the exact same radicals or exact same numbers underneath. That's it. Okay? So like radicals are terms with the same index, meaning they're both square roots, they're both cube roots, and radicand, whatever is underneath is the same. Sorry, it should be same in, I'll just put indexes. Same indexes and radicands. So for example, 2 root 5, 3 root 5, they are like. Three root 7, comma 4 root 2 are not like. If they are like, we can combine them by adding or subtracting the numbers in front of them. Called the coefficients. That's the word that we use. So given that thinking, what would this one be? A. They're like radicals. I can combine them by just going 2 plus 13, and I get 15 root 7. Okay, pretty straightforward. How about the next one? Can I subtract them by the way they look now? No, because they're not the same numbers underneath. Is there something that I could do to one or more of the radicals that we just learned? Well, not reduce, simplify. Is there a highest perfect square that goes into 6? 2 is not a perfect square. 3 is not a perfect square. 4 doesn't go into 6. Come on, you guys. Why do you always assume there's an answer? Well, there isn't. There's no perfect square that divides evenly into 6. What about 54? 9. So I can split this up into square root 9 times square root 6, which means I can further simplify this to 3 root 6. So I just simplified the second one, and notice what happens now. Now I can subtract them. Remember, root 6 is the same as 1 root 6. Yes, so what's our answer? -2 root 6.
Negative 1 minus 3. Oh, this is imaginary.
Okay? Okay, good. Yeah, no, fair enough. Nope, we're all good. Cool, this one. None of them are the same. So I got to look to see if I can simplify one or more of them. Well, don't get thrown by the 2 in front. So 2 times, can I break down root 12?
Yes.
So what?
4.
Say it properly. Root 4.
Yes. Root 4, root 3.
Root 4, root 3. Plus 3 times, can I simplify this one? Highest perfect square. Root 25. Root 2. Minus 2 times. There's a highest perfect square that goes into that one. This one.
It is
4 times 8 is 75. Is that the new math? Thank you. Root 25, root 3. Minus 6 times.
This would be on root 4 and do 8.
You didn't find the highest one.
What? 16. Oh. 16.
Root 16
If it's 4
times root 2.
This is really just
Okay, now let's simplify. 2 times 2 root 3 plus 3 times 5 root 2 minus 2 times 5 root 3 minus 6 times 4 root 2. Making it easier. Well, can't I multiply the non-radical numbers in each one? What's an easier way to say this? 2 times 2 times root 3. 4 root 3 plus 15 root 2 minus 10 root 3 minus 24 root 2. And now I've got to combine like radicals. 3 times 5. Because it says right here, 3 times 5. Yeah.
Sorry.
When you've got two numbers beside each other, one in parentheses, it means multiplication. That's okay. Okay, so let's combine the root 3's. I've got 4 root 3 minus 10 root 3. Minus 6 root 3.
You're so smart.
I've got 15 root 2 minus 24 root 2. And I can't put these two together because they're not like radicals, so that's as far as I can go. That's it.
It's really hard.
Okay. Well, some of these questions take a little bit of work. Good for you, builds character. Okay, this one. Well, we can't combine them right now. But we did learn to do in the last lesson when we had a number times a variable inside. Split. Root 20 times root x. I am. Minus 2 times split. Root 45 times root x. Now I look at all the square roots and I see if I can simplify them.
Yeah,
What other one?
like this other one. We don't.
I just said at the beginning of the question, if underneath the radical there is a number times a variable and possibly times another variable, that's when you always split.
Okay. I missed that part too. We're so fast. 50! That was not subtle.
I had something in my eye. I went like this. That's all. Okay. Root 20. Can I split it?
Yes.
To what?
45.
Say it properly, you guys.
You're
Thank you.
welcome.
There is no perfect square that goes into this. I can't simplify root x. So I just leave it. Minus 2. Can I simplify the root 45? Root 9, root 5, and I still have a times root x after that, which I can't break up. You should, yes.
Would it be wrong?
No,
Yeah, I didn't put it in a bracket. Oh, you didn't put the first one in the bracket either. Because it wasn't meant to be.
anyway, I'm okay if you don't have the parentheses. I see no brackets here.
Yeah, right.
What's the square root of 4? Times the square root of 5 times the square root of x minus 2 times, what's the square root of 9? Times the square root of 5 times the square root of x. Okay. Now, the first term, I've got 2. What can I do with the 2 square roots when I multiply them? Can I put them under a single one?
Yes, yes.
Root 5 times root x is root 5x. Minus, well, 2 times 3, and root 5 times root x, root 5x.
I feel like you can simplify them.
Finally, I got to like radicals. minus 4 root 5x. Excellent.
Where? That's a lot.
Wait, hold on.
So
Oh, I get it.
Neither do I.
Let's stay calm. Okay. You've got practice to do now, okay, in which you can ask questions and you gain a better understanding. Remember, these are just a few examples we did. In order to get a better understanding of it, you need to practice with it. You don't need to say, as soon as we do one example, I don't get it. That's not helping you, and it's not helping everyone around you. Okay? We got to be a little bit more positive. Okay? You guys can get this. If it doesn't initially come, it will come. As long as you pay attention.
We are.
Not just now, you weren't.
But I heard this.
Well, you didn't hear what I said before when I did one of the questions. You asked me to explain it. And I said, just like I said, and then I explained it. Oh, I didn't hear that.
Well, you didn't.
Yeah, right. Hence the two that I'm talking to right now.
What to say?
Oh. That was good.